In the previous video, we covered Boolean expressions and their evaluation process. Typically, a Boolean expression consists of logical or relational statements with values of either true or false. These expressions serve as the conditions within selection statements. In this video, we will solve problems involving selection or conditional statements. Each problem will be examined for specifications, algorithm design, and representation through pseudocodes and flowcharts, followed by the translation of algorithms into Python programs. Here's our example of a conditional statement in one of the previous videos. In the morning routine, we do a set of actions if it's a school day and do another set of actions if it is not a school day. In selection statements, we evaluate the condition first and perform statements if the condition is true. Problem 2. Create a program that computes for a student's final grade as the average of 3 marks. Determine if the student passed with a score greater than or equal to 55 or failed with a score less than 55. Before designing our algorithm for this problem, we need to first dissect the specifications to determine the valid inputs, the process, and the expected output of the program. For this problem, the inputs are the 3 marks given by the user. Our algorithm will follow the following process: get inputs from the user, get the average by computing the sum of the inputs and dividing them by 3, then determine if the average is greater than or equal to 55 or not. Then the output is a string pass or failed. Here's the pseudocode and the flowchart for this problem. Read 3 inputs and save them to variables x, y, z. Add x, y, z and save the result to variable sum. Divide the sum by 3 and save the result to variable average. Check if the average is greater than or equal to 55 or not, then print the result. Let's translate our algorithm to a Python program. First, we get the inputs from the user, then typecast the inputs to float since grades are usually floating point values. Get the sum and the average. Then use a conditional statement or the if statement in Python to check whether the average score is greater than or equal to 55 or not. If average is greater than or equal to 55, print passed, else print failed. Here's a sample run of the program. In problem 2, we use the most basic form of a conditional statement, which involves a condition, a true branch, and a false branch. In the next problem, we will deal with a more complex form of conditional statement. Problem 3. Write a program that determines whether the input of the user is positive, negative, or 0. Based on the specification of the problem, the user can provide any value to the program as long as it is numerical. So our program must accept a floating point value. Now we need to determine if the number is positive, negative, or 0. We are going to use relational operators for this. We will print 0 if the input of the user is 0. A positive number is greater than 0, and a negative number is less than 0. Let's write the pseudocode and draw the flowchart for this problem. Get an input from the user and save it to variable n. If n is less than 0, print negative, then terminate the program. If n is greater than 0, print positive, then terminate the program. Otherwise, print 0, then terminate the program. Here's the Python program for our solution. Get an input from the user, typecast it to float, then save the value to n. Then we use the if-else statements to check if n is positive, negative, or 0. If n is less than 0, print negative. Else if n is greater than 0, print positive. Else print 0. Here's a sample run of the program. Problem 4. Write a program that determines if the input of the user is divisible by 2 only, divisible by 3 only, divisible by both 2 and 3, and not divisible by 2 and 3. For this problem, we will accept any integer whether it is positive, negative, or 0. In order to determine the divisibility of an integer by another integer, we are going to use the modulo operator. The modulo operator returns the remainder of an integer division. For this problem, the input is divisible by 2 if the result of input modulo 2 is 0, divisible by 3 if input modulo 3 is 0. There are more than one possible solutions to this problem. What we will discuss is just one possible solution. The output would be a string stating that the input is divisible by 2 only, divisible by 3 only, divisible by both 2 and 3, or divisible by neither 2 nor 3. Here's our algorithm for this problem. Ask the user for an input and save it to n. If n modulo 2 is equal to 0, proceed to checking if n modulo 3 is also equal to 0. To determine if n is divisible by both 2 and 3, or just divisible by 2. If n modulo 2 is not equal to 0, check if n modulo 3 is equal to 0 to determine if it is divisible by 3. If it is, print divisible by 3 only. Otherwise, print divisible by neither 2 nor 3. Here's how we translate our algorithm to a Python program. Get an input, typecast it to integer, then save it to variable n. If n modulo 2 equal to 0, check another condition. If n modulo 3 equal to 0, print divisible by 2 and 3. Otherwise, print divisible by 2 only. L if n modulo 3 is equal to 0, print divisible by 3 only. Else, not divisible by 2 nor 3. Here's the sample run of the program.